Simulation automation. Fingers or scripts. Their strengths, fragility, and possible alternatives. Let's take a look at our data mining habits and workflows. It might be time for a re-evaluation. I have observed the authors of automation agents for decades and written quite a few myself. I started out to document a specific technique. But as I took a closer look, I was reminded of the host of fragilities to the everyday magic that we deploy, as well as how we choose to create and maintain them. I think it might be well past time for the simulation community to consider some of our habits and choices. As always, ESBR is the context for my explorations. Let's see if you have also noticed these fragilities. Rather than yet another block of Python code or a bash script, let's start with workflows where the practitioner's eyes and fingers reign supreme. User-directed explorations, well, they're hard to beat when it comes to really understanding how a design performs. Our traverse of performance data, looking for patterns, and then drilling down to find what the causal factors are, that can yield insights that can deliver really great value for clients. Way beyond the usual suspect workflows, the ones that you might have inherited and just couldn't be bothered to make your own. And rather than dump the usual standard report on your poor client, why not save some time? Intentionally go exploring that massive trove of performance data that you've just been making and look for the performance metrics and the forms of presentation that would really help you tell a great story about what you have found. And that kind of value-added narrative, well, it's going to need a crafted approach to data mining. When we get to the what-ifs and parametric tweaks, direct interactions, i.e. cranking the handle, well, that starts to become soul-destroying. And it's a magnet for errors. What do I mean by this? Well, I remember visiting a group in Florence, Italy, who were undertaking parametric studies. And for each tweak that they were making, they manually drove the results analysis module of ESP to generate their tables. It was taking them so long because they had to factor in time for reruns for their finger slips. The thing is, they didn't have an idea about scripting. Our documentation never really talked about how to leverage the tool by way of automation. So, while I was in their offices, I created what I'll call a coffee break automation. Literally, within the period of a coffee break, we took an idea, I observed how they implemented it. I asked some questions. I then implemented an agent to do that workflow, tested it on them, and handed it over to them. Now, it's tricky to get an automator to say how the magic's made. About a minute and a half into that linked video, you can see an interactive session of an automation being created. But for purposes of this video, the code I implemented way less important than the evidence I was gathering from the group, what I was attempting to observe of their procedures. What was I thinking about when I was going through this? So, here's that story. First, I switched into my most pedantic mind frame. And then I told them to proceed really slowly, and as they did stuff, talk to me about what it was they were doing. So I observed their workflow. I asked some questions, and then I asked them to repeat the task while I transcribed what was happening into my own copy of their model and my own copy of the software. I then tested that automation out and got them to look at the outputs it produced versus what they were producing by their manual methods. And when we'd tidied that up, I added some notes to the script and then handed it over to them and said, "You try it. Let's see if you can break it." And indeed they did, and we went back and we tweaked a couple of things, and it got a lot more robust. Basically, what they had been taking minutes per model to do became a few seconds. It paid for itself after they used it a couple of times. Now, an automator who's a seasoned user of the simulation suite, well, the next step, they might actually start to talk to people about how they might actually improve the workflow. But that's a separate skill. It's a minor investment to shift a practitioner focus. Now, having done it hundreds of times, that minor investment often can turn into a rather seriously pedantic path if there's a glitch somewhere into transcribing the observations. In that linked video, a little bit further along, I describe getting the tool to do the transcribing. And as I said in that video, goodness, why didn't I spend a day adding that key logging to ESPR a decade ago? It would have saved so much trouble. So, can coffee break automations scale? Well, they can certainly easily slide into an afternoon's work or a long weekend as people say, "Ooh, could you add this? And could you add that?" Thinking back on it, perhaps it's best to consider, if we want to go further, treat things as proofs of concepts to learn from, and then toss away once the next generation of agents start taking shape. And at some point, we really need to do talking about what's the half-life of an automation agent. I mean, many of them are tied to a specific project. If you find one in a model folder, yeah, it's probably a clue as to what its scope is. But some scripts, they address recurring topics. How can we make them actually be reusable, be robust enough? Well, when I was talking about adding notes and getting others to try and break things, well, that's certainly some of the steps that you go through. Hey, this does some rather nice magic. Well, pick another similar past project and try it on that. If that works, why? Go ahead. Put it into the distribution of the simulation suite. Put it in some example models so that it can actually be used. The thing about automation is that they need to be subjected to regular testing, or their fragility is going to cause grief sooner or later. Some scripts actually prove to be proof of concept for something actually you decide, hey, we ought to put this in the actual simulation tool itself. Again, that's a topic for another day. And what about automation at a rather grander scale? Well, validation studies such as best test, or the kind of checks that software development teams would like to run quite often. Well, they'll specify specific performance attributes to be tracked across some matrix of models. For example, the ESPR tester suite traverses a matrix of about 200 simulation models, runs multiple tests on each of those, and it's controlled by a 4,500 line Perl script. That's a serious bit of software. Although a seriously motivated practitioner might accomplish this kind of test manually once, maybe twice, by the third time they tried to do that kind of thing, people would look at them and know that they were utterly demented. When we're talking about a large-scale problem and possible large-scale solution to it, look, you've got to have resources equal to the task. And clever coders and researchers, well, they can be transient. And that is the wake-up call for the community. So what are these fragilities that I've been talking about? My observation is that script authors can be really clever folks, include some magic in their stuff. The thing is, well, users, they're kind of good at letting out the magic smoke. And users have vastly different expectations than script authors. Users, well, they're not quite sure what they're seeing as the script does its job. So, for example, they might uncritically believe the summary reports that are coming out of it. Hey, I got caught out during a testing, these files are equal. It passes the test. It just happened later on to go in, look inside those outputs, and found, well, yeah, they're equal, but they're equally full of not numbers. The other thing about the magic automations is that they can be really opaque to future maintainers. When I tried to update that legacy 4,500-line Perl script to work with a newly evolved simulation engine, well, there were clearly pockets of the kind of terse magic that Perl is known for. Of course, hey, Python can also host terse magic. Unpicking magic is really scary. And long after the authors of an automation agent have moved on, the next generation of developers is, well, they're confronted by thousands of lines and scores of functions and somebody else's idea of documentation. The other thing is, simulation tools and their interfaces evolve. Add a new menu option, and the script can break or worse. It's hard enough to resolve glitches in a really simple coffee break automation. Something that's got thousands of statements, hey, that's seriously daunting to patch. When I was looking at that Perl script, it kind of came out that, look, in order to do this, I'm going to have to add Perl Ninja to my CV. And goodness, yes, I've done some Python, but Python at that scale is also so much of a stretch. Essentially, hey, that Perl was at an end of life and beyond the skills of the community to maintain. We need to be careful when we set those kinds of things up. When I've talked to the authors of automation tools, and some of them were my colleagues, about their work, some trends kind of stick out. Automators assume that simulation tools are immutable. Almost without exception, it does not occur to them to ask for alterations in the simulation tool to make their work easier. Ask if they had a wish list for the next generation of the simulation tool, and, well, they're just puzzled. But basically what they come back with is, please, never, ever, ever change. That simulation tool should be carved in stone and left that way. That's how we like it. And automators thrive with static menu hierarchies and options for selections. And unfortunately, design teams are really good at asking questions that, well, there's not an answer to unless we put in some new methods and perhaps some syntax to support that. And, well, there are all these PhD students and they're doing research and new stuff going in. Again, to never, ever evolve the simulation tool, that's a difficult promise to keep. And automators thrive with static file formats because they can then do some of their magic to edit the model files. And if they can apply enough magic, wow, they could create thousands of model variants and bragging rights for how much CPUs they can melt. As a paranoid tool developer myself, I kind of tend to want to ask them the nasty question of, how do you actually prove that the 423rd variant that you created is both syntactically and semantically correct and meaningful? We need to be able to have testing regimes that test automation agents. And automators, they're not a very patient lot of people. They assume it's easier and quicker to implement a script to reform reports or other sorts of things coming out of the simulation tool than to add options into the simulation tool to simply produce better reports. So, what did I do for that 4,500-line Perl script that was just too scary to touch? Well, I observed what was actually being carried out, what was being generated, as the various matrix of tests were being carried out. And I looked around, and I found blocks of code in ESP that actually were doing similar things for validation work. I implemented an interface, a directives parser, logic to invoke assessments and drive data mining and scan the reports and capture differences, and it took about a third of the lines of the code in the Perl script. So yes, it doesn't all have to be out in the automation script. And again, and actually it was quite simple just to go into the simulation report generation facility, add some options, bang. And then all of a sudden, really horrendous bit of magic logic all of a sudden simplified out into one command. Again, working together, we can potentially get much further. So if some of these things are what also bugs you about simulation practice, let's have a talk about it. Let's see if we can work out some other ways of doing things.